Okay, what you're going to find in this chemistry course and many of your other courses is that a big part of learning chemistry is actually learning the language of chemistry. And you'll see that as you work problems and read through the chapter, you'll spend a fair amount of time looking up terms, either using your textbook or possibly other online resources. So in this course, we start off by showing you a systematic method for naming simple compounds, or a nomenclature. And we start with the binary inorganic compounds. Just to review, by compound, we mean matter composed of more than one element. Okay. By inorganic, we mean compounds that are primarily not carbon compounds. And then finally, binary means that we are looking at compounds that composed of two parts. So these are a little bit simpler to name, and we're going to go over the sort of formal methods for naming them. Now, the types of compounds that you will have to name fall into two categories: the ionic compounds, or salts, and molecular compounds. For ionic compounds, the binary refers to the fact that they are composed of two types of ions. So we just have one type of cation and one type of anion that compose the ionic solid, and that makes them somewhat simpler to name. So for instance, sodium fluoride, right? This is composed of one cation, the sodium plus, and one anion, the fluoride. Other types of examples of binary ionic solids would be Kcl and silver nitrate. Notice that the NO3, right, this is Ag, silver, and then NO3, which is a nitrate. The NO3 makes it look like this is more than two parts, not binary. But the fact that it's one type of anion, though it's composed of more than one atom, qualifies this salt as being a binary ionic compound. So again, the binary refers to that there are two types of ions, just one type of cation, one type of anion. So for molecular compounds, the binary refers to that there will be just two types of atoms that make up the molecule. Okay. Examples of those. Okay, so here's one example of a molecule composed of carbon and oxygen only. And then two more, CO2 and N2O. So again, they have just two types of atoms. And of course, there can be many more than just two atoms total in the compound, but they're just of two types. It's going to be important that you be able to recognize the difference between ionic and molecular compounds just on sight by seeing the compound, because the naming systems for the two will be just slightly different. They're similar, but there are some slight differences between the two that you'll have to be able to note. So they use similar, but slightly different rules for naming. So as I mentioned, one of the first steps in naming these compounds will be to be able to recognize whether the compound is ionic or molecular. And we talked about that in previous parts of the course. But in general, ionic compounds, you will see, are made up of a metal and a nonmetal element, whereas the molecular compounds will be made up of only nonmetals. So we have two naming systems, and you'll find that they're very similar, and that is an advantage in terms of memorizing, but also a disadvantage in which, in the case that sometimes students will mix up the two methods if they're not clear on whether the compound's ionic or molecular. So the first step in naming ionic compound is to name the cation. So pretty straightforward. And the second step, name the anion. Okay, now the devil is in the details. What we're going to do to name these two depends on a little bit on the type of ionic compound, but there's not much differences. Here's a few examples. A ionic compound made of calcium and fluorine, one composed of iron and chloride, and one composed of sodium, and the CO3 is a polyatomic anion that's called carbonate. Okay, so for each of these different ionic compounds, we will name them in two steps. First, we name the cation. Secondly, we name the anion in each of the solids. Naming cations is fairly straightforward. And for simple cations, that is, cations that are composed of just one atom with a positive charge, they just simply take their name from the name of the element. So if you know the names of the elements, this is pretty straightforward. However, for transition metals, the cations get a little bit extra designation. And that is, cations are followed by a Roman numeral to indicate the charge. And that's because for transition metals, and these are the metals that are sort of right in the middle of the periodic table, those metals can have varying oxidation states. +1, +2, +3, even for the same metal, as opposed to the alkali or alkaline earth type metals like calcium and lithium and magnesium. Those have only one oxidation state, +1 or +2, for instance. So since transition metal oxidation states and thus the degree of their positive charge can change, we need to indicate what it is when we write it in the name, and we'll show an example of that. Finally, for polyatomic cations, we simply have to memorize with the name of those, and there's usually a table in your textbook of names that you can memorize. So the most common example is the NH4+, which is ammonium ion. That's probably one of the few that you'll see in this course, but a few more might come up, but it's worth memorizing that particular one. For naming the anion, this is also fairly straightforward, involves one extra step. For simple anions, they are named from the root of the element followed by IDE. So we start with the first part of the name of the element, like oxygen, and add IDE, so oxide, for instance. Or chlorine becomes chloride. And we take off the end and add IDE, and that's it. However, there are many polyatomic anions, and those we again have to memorize the names. And we try to keep memorization to a minimum, but and many of these you will know just from experience and using over and over again. However, there's a table of anions in your text, and you should look to that table and practice recognizing those anions with their names. Okay, so let's practice a few. We'll start with the ionic compound composed of calcium and fluorine over on the right-hand side. We start out naming the cation, and again, looking at the rules, this is a simple cation composed of calcium, just one atom, and therefore it takes its name from the name element, so we just write calcium. Now, the anion is composed of fluorine with negative charge, -1 charge in this case. So we're going to start with the name fluorine and just use the first part. Remove the INE and add IDE, calcium fluoride, and that's it. Let's try another one. Iron is the name of the cation. It's a simple cation composed of just one type of atom. Now, in this case, iron is a transition metal, so we're going to need to follow that name with a Roman numeral to indicate how much positive charge is associated with the iron. Is it +1, +2, +3, so forth? The way we can figure it out is by using the ratio of iron to chloride in the ionic substance and the known negative charge of the chloride ions in the ionic compound. So chlorine, if you look at the periodic table, right, is in the halogens. Those carry as ions -1 charge, and so we know, and since there are 2 of them, there will be a total of 2 negative charges. Now that has to be balanced by positive charge on the iron to make a totally neutral compound. Therefore, the iron must be +2. And so now we can write behind iron in the name a Roman numeral 2 to indicate that +2 charge. Followed by naming the anion. We start with chlorine, we drop the INE and add IDE. Okay? And now let's name one more as an example, one composed of the sodium and the carbonate. Okay, so since sodium is simple, a cation composed of just one type of element, it is named just from the name of the element, so we write sodium. And then CO3 has a 2- charge. It is a polyatomic anion, and we simply have to memorize a name. This one is called carbonate. You'll find that in a table of polyatomic anions in your textbook. So we write carbonate. And that's it. And now we've named 3 ionic compounds using this simple sort of set of rules for naming them. Okay, so for molecular compounds, the naming system is very similar, but has one slight change, and we'll see why with these examples: N2O4, NO2, and N2O. Notice that these all contain the same type of atoms, but in different proportions. So our naming system is going to have to take into account that for molecular compounds, you can have lots of different combinations or ratios of the different types of atoms. So in this case, we have one that has two nitrogens and 4 oxygens, and also one that has only 1 nitrogen and 2 oxygens. So we have to have a naming system that can account for those differences. So for molecular compounds, first step, simply name the first element in the compound, and this is going to be using a similar method to the ionic compounds. We just name Name derives its name of the first element is just the name of the element itself. Okay, so that's there's no modification. Second, name the second element. Now here we're going to have a little bit of a modification, but it's going to be the same as what we used in the ionic compounds. We're going to start with the root of the name followed by IDE. So root of the element name followed by -IDE. So again, oxygen would become oxide, chlorine, chloride, fluorine, fluoride, and so forth. Finally, we're going to add prefixes to represent the number of atoms in the compound. So this is very important, and this is the major difference between the ionic and the molecular compounds, because the charges on ionic compounds are relatively fixed. They're going to have relatively fixed proportions. But for molecular compounds, it can vary quite a bit, as we see in the example of these nitrogen and oxygen compounds on the right. So the prefixes are going to allow us to distinguish between these different types. Be very careful not to mix up and use prefixes on ionic type compounds. It's a common mistake. The prefixes are ones that you're going to have to memorize a little bit, although you might be familiar with them. We use mono for 1, di for 2 atoms, tri for 3, tetra for 4, penta for 5, hexa for 6, and hepta for 7, and so forth. Probably we won't go much beyond that anyway. So let's, I put this in red just to, again, distinguish it in the molecular naming system versus the ionic naming system. So now we see these examples of molecular compounds. Let's have some practice at this with the first one, the N2O4. Right? I start by naming the first element, and it just takes its name without any modification, so nitrogen. The next element, name the second element, is oxygen. Right? So the root, in this case, is going to be OX only. Okay? So we have oxygen. We remove that latter part and add IDE, oxide. So nitrogen, oxide. So we've done the first two steps. Name the first element, and then name the second element based on the root of the element name followed by IDE. And then lastly, we're going to add the prefixes to indicate the number. So there are 2 nitrogen atoms, so we're going to use di. And there are 4 oxygen atoms, so we'll have to write in tetra. Looks like I don't have much space, so I'm going to squeeze this. And then in this case, since it sounds kind of funny to have 2 vowels together, we often drop the A out of the tetra and just make it tetroxide. I want to rewrite that a little nicer. There we go. Let's do another example. The next compound with nitrogen and 2 oxygens, so this again is going to be a nitrogen oxide. Nitrogen is named first, followed by oxygen with the IDE ending. And now we're going to distinguish it from the previous one by adding the prefixes. We have 2 oxygens, so it's dioxide, but we have 1 nitrogen. However, whenever your compound starts with 1 atom of an element, we leave off the mono. So instead, we just assume that it's just 1 when it's the first element. Okay, so nitrogen dioxide rather than mononitrogen dioxide. We just leave off the mono. Let's do one more. Our last nitrogen oxide compound. So name the first element followed by the second element with the IDE ending. This one we will distinguish There's 2 nitrogens, so we write di. And then there's just 1 oxygen, and so we are going to add monoxide. We will leave off the O at the very end, so we don't have monooxide. We make it sound a little nicer by writing monoxide. So dinitrogen, monoxide. Notice that in this case, since the oxygen comes second in the compound, we do tack on the mono to indicate that there's just 1 oxygen. And that is a systematic naming system for naming binary inorganic compounds. Next job for you is to practice as much as you can so you can get as familiar with the system as possible.